Well, what do you say we get started? Welcome, everybody. The agenda for today, we'll go over a few miscellaneous project updates and then spend most of the time talking about the upcoming 3.4 release that we're aiming to get out by the end of the month. The substance of that is two issues that we'll talk about: the collaboration with the Color Interop Forum and the introduction of some new metadata, the Color Interop ID to support that. And the bulk of the conversation today, I think, will be on the new high throughput JPEG 2000 compression. Um, Before we get into it, let me give a brief plug for the open source days on Sunday, live in person if you're in Vancouver for SIGGRAPH, or virtual. A full day of interesting content, and go to the ASWF website for information for the program and to register for it. Another plug for our semi-annual Dev Days. This is an effort organized by the Academy Software Foundation to encourage first-time contributors to open source projects. But I'd also like to put in the plug for possibly more senior folks to just take this kind of opportunity to maybe step up and make a contribution. We can certainly use the help. Um, I assume everybody here knows what OpenEXR is. Professional grade high dynamic range storage format for the motion picture industry, developed at ILM in the late 90s, early 2000s, with contributions over the years from Weta, DreamWorks, and a bunch of others. Charter member of the Software Foundation, 2019. Um, our steering committee is intact from 2019. Uh, Kimball has the informal title of project architect and does the heavy lifting in the development of the library these days. Rod was one of the original developers. Peter has made substantial contributions in the past and current, and the others, me and Christina from ILM, and Larry and Nick. Um, One point to make is that this is very much a part-time volunteer effort. This is not a project that has a full-time team budgeted and staffed by any of the member organizations. This is all time that we squeeze out of our busy day jobs to contribute to the library. Again, a plea for help. Um, I think it's worth just kind of reviewing our statement of our mission. What we value is primarily stewardship of the library: robustness, reliability, security, compatibility, performance, simplicity. Um, this is not a library that should see a huge amount of feature churn. It's very mature, and primarily our job is to see that it maintains its place as the preferred image format for the industry. I will say that uh, you know these are our stated values, not that we necessarily always live up to them in every single commit, but this is what we strive for. Um, to go over a little bit of kind of well, this point worth mentioning: the Academy Software Foundation, Linux Foundation arranged for a security audit of the project. In tandem with Material X, we both went through this at the same time. they contracted with a security contracting firm starting in January. They took the library and um, put it through a battery of tests, their own fuzzing testing, in addition to the fuzz testing that we use through OSS Fuzz. And their analysis, they uncovered four what we would call bugs. They were kind of just garden variety bugs, which Kimball fixed pretty straight away. We released them we released the fixes back in March in the 3.3.3 release, and this report has just been published last week, I think. You can read it, and it describes what the vulnerabilities were. Again, we would have regarded these as just garden variety crashes or bugs, but anyway, I think the takeaway from this is it's a pretty secure piece of software. They did make some recommendations on how we can improve our fuzzing process, which we'll kind of act on at some point. Looking forward to the release for next year. Uh, Miscellaneous stuff. I'll pass it to Kimball in just a minute, but one of the, I mean, actually, let me back up a bit. And the 3.1 release from a few years ago was Kimball's complete rewrite of the uh, file IO process with an entirely new library that is set up to be substantially more performant. It handles memory allocation much more efficiently and makes it possible to multi-thread the library in the way the C++ API does not. The 3.2 and 3.3 release saw more of that functionality get integrated into the C++ API. Um, um, One of the things that we're rolling out in an effort to simplify the whole process is eliminate the dependency on libdeflate by vendoring the code into the library. Um, uh, Kimball, you want to say anything more about what might be um, coming along those lines?
Yeah, sure. Thanks, Carrie. Yeah, the I guess 3.3 saw the rewrite of the C++ read side of the library, and replacing all of the compression routines with using that core library that Carrie mentioned. And 3.4 will see the right side of that get switched over. There should be relatively minor. There's a couple more constructors basically to the existing classes, and the previous constructors should continue to work just fine. I know it's exposed a couple of changes that need to be propagated downstream into things like OpenImageIO as we go, but that's fairly minor and straightforward. One of the other things to mention that we started and been working on for the past year or so is sort of building up a tool set where we can have good baseline of performance. I wouldn't say we have, it's somewhat hard with the various CI/CD mechanics to actually have rigid performance metrics get captured everything, but we try to run them reliably. But we sort of have the ability to generate tables of performance, and some of the formats are reading quite a bit faster. I forget what the actual multiplier is, but anyway, I think that's probably the biggest change, and we'll have some more cleanup, and with the ultimate goal. And the reason I did the core library was to make it such that eventually, it's going to take a while because we're sort of a stable library. We're doing this very, very gradually, but the idea being that eventually we have a fully backwards compatible ABI that then allows new versions of the library to uh, coexist in older versions of the VFX reference platform. such that, if there is some sort of significant performance thing that we fix, we can continue to support um, older versions of the VFX reference platform with a newer version of the library, which will be a big step forward. And so that was sort of one of the other motivations behind that. That's probably enough, Carrie. Do you want me to talk about any other stuff, or you maybe you keep going?
Maybe, does anybody have any questions there? We're not having an official birds of a feather at SIGGRAPH, but if you're interested in talking about any of this stuff, reach out to Kimball. Kimball will be
Yep.
there. One other small addition that I wanted to mention was a new attribute type, the bytes attribute. And this is a new attribute type that just holds a binary blob. Um, um, the use case that precipitated this at ILM was to be able to store a pickled Python dictionary to pass around with inside of an OpenEXR file as opposed to having to manage a sidecar file. So this is the kind of thing that there's a good chance people will find a lot of different ways to make use of. So the attribute type just holds a size, an array of bits, and a type string to go along with it that is a user-defined tag to as a hint to how to interpret the data, but the library itself is not going to impose any kind of restrictions on the format of the data or how to interpret it. That's going to be up to the application side. And with that, I'll pass it over to Carol. Carol, you want to just shout out when you want me to advance the slides.
Yeah, sure. Doug and I are going to tag team this a little bit. So I'm going to do first couple and he's going to do the last because that's what we do. So I'm here. Just thanks for the space in your town hall, Carrie, to talk about the Color Interrupt Forum. For those that aren't familiar, the Color Interrupt Forum is a forum that we started within the ASWF about a year and a half ago now. And you can see on the slide, it's truly what we want it to be is a space where folks can come to discuss their interoperability of color workflows and standards and just an open space because we're all super aware that color is hard and interoperability of it is even harder. And so we're making a space to try and do that because we have so many projects within the ASWF that are dependent on each other. And then so many applications that are dependent on all of our projects. And what we realized was we were spending a lot of time kind of trying to cross these things together and get everything to meet up. So we made a space where we can do that. So we meet monthly, Mondays at 12 p.m. Pacific. We have our Color Interrupt Forum Slack channel on the ASWF Slack. And this is a place where you can come to talk about color regardless of whether it's OCIO related or not. Obviously, Doug and I both represent OCIO very strongly and are very passionate about it, but we really come at it from a place of OCIO would like to help make this interop better. And so if there are things OCIO can do in addition to other things in order to make best practices work better and add new features, that's what we would like to do. And so in that regard, that's what we're here to talk about today. And one of the first things we did on the next slide, the first initiative that we did was publish a document called Color Space Encodings for Texture Assets and CG Rendering. It is published on the Color Interrupt Forum's GitHub. You can access it by this QR code here. And it's guidelines for, as the very long name implies, standards and definitions for common color spaces, scene referred color spaces used in assets and CG rendering. And so it's relevant to OpenEXR. All of these color spaces are ones that, at least in the fully linear versions of them, are used in OpenEXR all the time. You see them a lot. And these guidelines of how to implement them are published and incorporated into OpenColor.io, OpenUSD, and upcoming in Material X. And so we're sort of propagating the names of these spaces and how they're defined into all of these different libraries for color interoperability. So this is published, and it was a first step for us to now then build on those definitions for the next couple things that Doug is going to talk about.
Great, thank you, Carol. So, Carrie, if we could have the next slide, please. So, as we've been looking at color interop across projects, one of the things that we run into is the fact that each file format has its own way of identifying color spaces, and we need to somehow identify correspondence between all of those. And so one of the things that we wanted to do is recommend a specific way of encoding color space. And the thing that we thought would be the most easy to understand, the most flexible, the most future-proof would be to have some sort of a name string. And this is something that OCIO obviously already uses a lot of. But we didn't want to just make it an OCIO color space name, because one of the things about OCIO is it's really, really flexible, and the color scientist at a facility has total freedom to name color spaces in a way that they think will be most meaningful and least error prone for the artists at their studio. So for any given color space, what it's called in a given studio, in some place it may be ACES 2065-1, in other places it may be Lin_AP0. And if that is what goes in a file format, it's going to be quite fragile, because that reference is going to be specific to a given config at a given studio. So we wanted to come up with something similar to a color space name, but more robust. And so the idea, this is what we're calling the color interop ID. It's something that is a string that is hopefully human readable, but it will be a standard thing so that everyone uses the same string. Now, this is something that would be in the OpenColorIO config itself as a separate attribute of a color space. You can read the draft specification using this QR code here, and we'd be looking for your feedback. This is a Google Doc, so feel free to read that and make comments in the margin on that. Next slide, please, Carrie. So, and we've got a second Google Doc here, and this QR code will take you to that one. And this is specifically for the guidance for what we're proposing for OpenEXR files. So as you know, OpenEXR has for a long time had a chromaticities attribute to communicate color space. We've found that it's just kind of not a reliable mechanism. And it's not so much because of a technical limitation, it's more what I might call application hygiene. In other words, like just not being diligent in terms of how this metadata is set and communicated. So for example, we want to discourage application developers from putting in sort of like a default color space if they don't actually know. So with the new attribute, there'll be an unknown string that you can write if you have to write it. Another common problem is people editing an OpenEXR file, changing the color space, but not resetting the chromaticities flag. And so this is a case where as long as we all kind of know what this color interop ID attribute is, hopefully applications can be more diligent in terms of resetting that appropriately if they change the color space. So a lot of this is around just making sort of the protocol for handling color space in OpenEXR files crystal clear for developers, so that we can have a fresh start here and really try to build trust in this as a reliable mechanism. So Carrie has a PR on the OpenEXR GitHub, and so we're hoping that this will become a standard attribute in the next release. And again, if you have any feedback on the proposal, we'd love to hear it.
Yeah, I just want to chime in on that feedback bit and say we know this is lots of new information and possibly seems like a big thing, even though it's one string, and it is. But we are trying to get this feature in the next releases of our respective libraries so that we can start to work on what I think is going to be the harder part. This is what Doug alluded to, is getting it treated correctly and implemented correctly and used correctly in all these different DCCs and workflows. And the longer we wait to get these attributes in our libraries, the longer it's going to take to get that to happen. So we would really like to get all the feedback you possibly have for this in hopefully a timely manner in the next, few weeks or so. We know that that's a busy few weeks. We respect your time. Hopefully these QR codes and the Google Docs make it easy to comment, but you can also always post anything or ask questions on any of our Slack channels, EXR or Color Interrupt Forum or OCIO, wherever you want to get a hold of us, or if you want to talk to us at SIGGRAPH. Both Doug and I will be there in person too. If you'd like to have a conversation, just find us.
Thanks, Carol and Doug. Any questions from the audience? I'll pass it over now to Pierre Anthony Lemieux to talk about HTJ2K.
All right, welcome everybody. So this is me, Pierre-Anthony Lemieux, and I'm a consultant to the industry. Some of you might have run into me into other contexts like cinema or time text, the interpretable master format. The work here is been made possible by Disney, so thanks to them. And also on the call are Aus Neiman, who's the maintainer of OpenJPH, which is a big part of this. We'll get to that later. And Michael Smith, who's done a lot of work in JPEG 2000 and has been a fellow traveler in JPEG 2000 across many different domains, including cinema and broadcast, and recently, and also in the work in maintaining JPEG 2000 in ISO and ITU. So that's me. This is really intended to be super interactive, so feel free to interrupt if you have questions. Not sure, can I see hands anyway? So maybe myself or Carrie can pick up hands and we can answer questions. And without further ado, let's go to the next slide, which I think is the key slide, is, why are we here today? It's because JPEG 2000, which has been really around for 20 years, and it's more than 20 years, and it's pretty remarkable because it's been continuously maintained since then. There's very few image or video codecs that have been continuously maintained over decades and extended. That's a testament to the flexibility of JPEG 2000. And JPEG 2000 has some features that make it uniquely desirable for EXR. And one of them is that it supports all the features that EXR exposes, and there are many of them. It's also an international standard that's already in use throughout Hollywood and studio applications. And because it's so flexible, it opens the door for advanced capabilities in the future. So we'll go over all those 3 points one by one. Up to recently, unfortunately, the CPU performance of JPEG 2000 was pretty terrible, and I mean that's been feedback that's been received by the industry, across multiple domains for decades, and that's something that Michael Smith, Aus, myself, and others like David Tomman have been working hard at addressing, and which culminated in the publication in 2019 of a new part of JPEG 2000, which replaces the slow arithmetic coder with a new block coder called the high throughput block coder, the HT block coder. And that increases CPU performance by more than 10x, in fact, up to 40x in lossless 4K images. So that improvement was published in 2019. It's been around for a while, as we'll see. It's been implemented across. It's now available across multiple implementations, and so it's felt that now was the right time to, reconsider the use of JPEG 2000 and EXR. And so this is why we're here today. Any questions on kind of the basis here? Otherwise, we'll get right into it. All right, next slide. Okay, so JPEG 2000 does everything, and it's good because EXR does everything also. JPEG 2000 can support up to 16,000 channels. You know, EXR has very, very flexible channel configuration. JPEG 2000 supports up to 38 bits per sample, which is good because EXR has 32-bit ints and floats. JPEG 2000 supports, 4 million pixels per dimension, which is good because EXR also supports huge images. JPEG 2000 supports integer and floating point samples out of the box. Flexible subsampling, supports YUV, so 422, 420, 444, but also Bayer pattern. Again, completely outside the box. In many ways, JPEG 2000 was really ahead of its time. And I think that's what penalized it early on, is because with that flexibility comes conceptual complexity, right, evidently. So anyway, and also JPEG 2000, really unique, supports both lossy and mathematically lossless coding in one codec. And so today we'll talk mostly about lossless coding for EXR, but it opens the door for lossy coding. It also supports out of the box decorrelation for RGB and XYZ channels. So the idea is that typically there's a lot of redundancy across the RG and B channels, and by decorrelating them, so a simple way of doing that is by converting them to YUV or a CBCR, you gain in compression ratio, right? By basically isolating the energy into one channel. So that's also supported by JPEG 2000 out of the box, but as we'll see later, it's possible to do even better. So there's a good fit for JPEG 2000 in EXR. And going to the next slide. So something else that's come up as well is, so JPEG 2000 is an international standard. It's been continuously maintained. The intent has been royalty-free since the beginning. It's already in use in studio application. It's used across the industry. You might not know, but it's required in PDF. It's used throughout the satellite image industry, and passport application, medical application, archival, Stanford archives, its image, for instance, image of maps using JPEG 2000. And one of the cool features is because it's an international standard, it can be referenced by other international standards, right? So to the extent that the EXR community ever wants to create an international standard around OpenEXR or around EXR, JPEG 2000 can be referenced by that standard. And the other really neat thing is because it's a standard and because there's so many implementations, supporting JPEG 2000 in OpenEXR is not limited to a single implementation. You can use any conforming JPEG 2000 implementation, right? We'll see. Today OpenEXR uses OpenGPH, which is an open source library by default, but you might have your own favorite J2K library, right? Kakadu or Compromato, or maybe your own, and you can just plug in and replace OpenGPH with your own implementation, and it will work outside the box because, again, JPEG 2000 is a standard. Okay. And by the way, that's demonstrated in just a little proof of concept I created based on a CAPI that we just heard about, where it basically substitutes OpenGPH with Kakadu in OpenEXR. And that can be done actually at runtime using the CAPI. So just at the bottom of the previous slide, there's a link to a proof of concept. For those that are interested, I encourage you to look at it. CAPI works great, by the way, super clean. The benefit, I guess, of hindsight. So anyway, that was actually a pretty pleasant experience. All right, so high throughput JPEG 2000. So again, quickly, this is a new development in JPEG 2000. Well, relatively new in the scale of JPEG 2000. It was published in 2019 as a new part of JPEG 2000. It is both an ITU and ISO standard. And again, it replaces the slow arithmetic block coder with a faster block coder, and that comes at a slight cost. You have a 5% size increase in the file, but it also comes with the benefit of much, much faster performance. I mean, for those of you who have used JPEG 2000, the performance is really noticeable, right? I mean, traditionally encoding a 4K image on a desktop computer takes a second about, and now we're talking, especially for lossless 4K images, 40 times faster. So it's like instantaneous. So it's really faster at a human scale. And the really neat thing is you can actually, because the change in JPEG 2000 is only in a block coder, which is the lossless part of JPEG 2000, even when you do lossy coding, you can transcode back and forth from legacy JPEG 2000 to high throughput JPEG 2000, completely mathematically losslessly. And you might ask, why would you ever want to do that? Well, an example, for instance, is that 5% size increase might not matter for a master or for OpenEXR that you're working with, but if you're going to store OpenEXRs in the salt mine or in Glacier, a 5% increase, I mean, if it costs you $10 million a year, 5% of $10 million is not insignificant. So you might want to actually losslessly convert to JPEG 2000 before doing long-term storage. And we're now 6 years from 2019, and HTJ2K is supported in popular studio tools like Resolve, Transcoder, uh, uh, Roden Schwartz Clips. Well, it's not Roden Schwartz Clipster anymore. Cinecert Clipster software libraries. It's in Kakadu SDK, OpenGPH, as we'll see. It's also in FFmpeg, so you can actually start FFplay and play J2K files or J2K IMFs, for instance. All right, next slide. So again, this is no longer, or HTJ2K is no longer a lab experiment, which is also why it felt it was a good time to bring it to EXR, which is definitely not a lab experiment. Okay, so the first thing I thought I'd do, right, is just actually see where we stand in terms of performance compared to other codecs in OpenEXR. There would be no point in introducing J2K if it didn't bring some benefit. And so one of the benefit, the assumption is it could bring some increased performance, both in terms of coding efficiency and throughput and speed. So did the quick evaluation comparing. So that was back late last year. So basically including or adding to OpenEXR main branch, two HTJ2K base compressor option, one based on our commercial library, Kakadu SDK, and the other one based on an open source library, OpenGPH, taking a open source ACES sequence made kindly available by Netflix on their website, and processing that sequence using the various codecs available to OpenEXR and comparing the results. And so that's what we'll see. I'll just summarize that in the next slide. This is all available on the original pull request. So for those that really want to go into the details of the numbers, I encourage you to go read the white paper. I'm just going to summarize them. So next slide, Carrie. All right, so compressed size relative to HTJ2K. So this compares, the size of the file, so the actually average size of the files, because the test sequence says that had about 30 files. So if you look at the average file size across the various compressor option, and you say that HTJ2K is size 1, right? So relative to HTJ2K, none, right, is no compressor, so the size is double, right? So that's about, I mean, it ended up being exactly double, right? It's not always going to be double, but typically for natural images, lossless J2K gets you about 50%, like grossly. So it turns out to be the most coding efficient compared to PIZ and Zip and Zips. So again, these are all in the ballpark, right? PIZ is 1.11 compared to 1.0, so it's 10% less efficient than J2K. But J2K turned out to be the most coding efficient on that sequence. So that was a good sign. And if you go to the next slide. So now in terms of speed, so again, this is encode and decode time per frame across the same sequence of ACES images. Again, I'm not going to go into, this is a truly an eye chart, right? I think we can, so something to notice, by the way, that's I think is pretty cool is HTJ2K or J2K in general, the compression and the encoding and decoding time is symmetric and also does not depend on the frame itself, right? Compared to PIZ, for instance, or Zip, that might actually depend on the complexity of the frame, right? So depending on how much run length you have, so forth. So HTJ2K is kind of time bounded per frame. And I think the next slide summarize the results. So in terms of speed, so this is single threaded results. The commercial HTJ2K library was the fastest, aside of course for none, right? I mean, no compression, right? It's just memory copy, but compared to PIZ, Zip, and Zips, the commercial HTJ2K library turned out to be the fastest. and across the board. And the open source HTJ2K library turned out to be the second fastest in decoding speed. And let's see, it's the opposite. It's turned out to be like the second fastest in encoding, but lagging in decoding. So anyway, so that was pretty encouraging, right? So HTJ2K was, if at least competitive, but probably outperformed other options in other compressor option in XR. So in terms of all the cool features you have with HTJ2K, you also get performance. So next slide. So my observation doing this kind of experiment, and of course, I mean, I think over time we'll get more samples of content, and we'll kind of improve that these overall observation. But in general, HTJ2K seemed to improve both speed and file size over OpenEXR compressors, but that performance of open source OpenJPH, which did not benefit from years of optimization as the commercial library did, can probably be improved over time. So these are my observations. And then, all right, so where are we today? About 6 months, or about maybe 6 to 9 months later, OpenEXR is available. HTJ2K compressor is available on the OpenEXR main branch today, so you can experiment with it today on the main branch. And the goal is to have it in the 3.4 release at the end of August. By default, it uses OpenJPH. Again, there are ways of plugging in your own implementation, but by default, it uses OpenJPH. Today, it's lossless only. We could, and this is, I hope we'll talk a little bit about this. There's the option of making it loss in the future. Today, for scanline files, it uses a 256 line chunk. That seemed to be a pretty so each 256 line chunk contains a complete standard JPEG 2000 code stream. It's a completely independent code stream, so it's an independent image, as well as a couple of bytes of channel mapping information. 256 seemed to be a pretty reasonable compromise between avoiding the overhead of header metadata, but also providing concurrency for scanline files. And again, one of the cool things here is, any HTJ2K decoder can decode the standard JPEG 2000 code stream that's stored in OpenEXR files. All right, so OpenJPH, I really want to give some kudos to Aus, who's I think on the call and is available to a question, because this would have not been possible within OpenJPH, which is a C++ implementation of an HTJ2K encoder and decoder, open source. It's available on GitHub at the address below. It includes Intel vector optimizations. And really, I mean, it's kind of the FFmpeg implementation is based on it, is inspired by it. The OpenJPEG implementation of HT is also based on it. So really kudos to Aus for all the hard work there and everybody that's contributed to that open source implementation. Now, I don't want to speak for Aus, and you might have questions for him. Potential to-dos, right? Again, we saw there's some, the performance can definitely be improved. We know it's possible because commercial libraries go faster. For lossless, of course, there's only one way to encode lossless images, essentially, so there's not much to be done there. But for lossy, commercial libraries have much more flexibility for tweaking lossy encoding. So that could be, especially if we go down the path of enabling lossy J2K in OpenEXR, that's something that we might want to spend some time on, improving support for lossy encoding in OpenJPH. And then there's some really geeky stuff about support for placeholder passes. Anyway, like any open source project, there's always something to do, and help and contributions, I'm sure, are always welcome. Aus, do you want to? I mean, I assume Aus is here, but if you are, do you want to say anything else?
Well, I would like to thank you and Mike for all the support that you provided over the years. I think you covered this quite well. Thank you, Pierre. All
right. Okay. Anyway, if anybody has questions, let's see. Do I see any hands up or? Okay. No. All right. So continuing on, next slide. All right, so the fun stuff is now that we have lossless HTJ2K into OpenEXR, we can look at some really cool future capabilities. And the first one is, of course, lossy compression. And that from a J2K perspective is relatively easy, right? So you just, instead of saying reversible, you say irreversible and you get lossy. Now, the there's some really interesting issues that come up that really I think we need to study, and Mike Smith can talk more about this, but issues was, for instance, of how do you handle lossy compression of not a number, right, of NANDs. OpenEXR has this huge dynamic range, so how do you get a good intuition on what's the right encoding parameters for those kind of images? Anyway, so there's some study to be done there for sure before like just gingerly turning on lossy, but it's available. Like we can start working on it now. The other one, which I have a cool little demo I talk about later, is one of the really, really neat features of of JPEG 2000 is resolution progressive access. And that, allows very easily that allows somebody to very easily retrieve a lower resolution of an image without decoding the full image. And so that has a potential of replacing bitmaps, right? Not have to burn in the file, lower resolution version of an image because it's already in the J2K code stream. So anyway, I have a demo next, so I'll talk a little bit about that. Another really neat thing is outside the box, JPEG 2000 supports basically decorrelation across any number and any kind of channels, right? So simple decorrelation is, of course, from RGB to YCBCR, but the framework of JPEG 2000 allows you to take, let's say, 60 channels and basically decorrelate all of them together and come up with the least, the set of channel with the least amount of correlation. And you might say, why would we ever want to do that? It's because OpenEXR files are often stored with a very large number of correlated channels, right? Especially if you have layers of related channels. So you might have, a depth chart, depth maps, normal maps, and all these are highly correlated. And so there's an opportunity here to decorrelate all those layers and those channels and make the coding even more efficient. So these are all possibilities that we can start studying today. They're all available in the standard, and it's really a matter of how to best use it for OpenEXR. Mike, do you want to add anything to that, or we can just take questions
No,
later?
I think you did a good job. I mean, we can continue working on this going forward, I think.
Okay. Yeah, so today, what's on the main branch supports only decorrelating RGB. Again, we have the option of doing much more than that. That, of course, requires the encoder, right, and the OpenEXR writer to actually identify those things that should be, decorrelated. So, I mean, it requires a little bit of work across the ecosystem, but again, the potential here is reducing file size enormously. I mean, I have some, gigabyte file size with 64 layers that are highly correlated, and so I mean, theoretically, this could be a much smaller file at the end of the day, even lossless. All right, so the one thing that I want to just whet your appetite with, to be completely candid, is the next slide. So it's a feature that's been in JPEG 2000 since day one is resolution progressive access. So it's possible to arrange the J2K code stream in such a way that all the lower frequencies of an image appear first in the code stream. And so what it really means is that if you want a low resolution version of the image, you just read the first third of the image, right? Or the first half of the image, or in fact, however much you can read, right? Because you might be on a CPU limited platform, or you might have a bandwidth limited channel. So you read as much as you can and you decode what you have, and you end up with a low resolution of the image. So no need to pre-create lower resolutions of the image, right? I have this hierarchical structure of of various versions of the image at various resolution. That's built in the code stream itself. That's built in JPEG 2000 itself. And so an example of that, and this is the next slide if you want to go. So this is something you can yeah, you can just go to that demo, right? And this is a demo that demonstrates one of this ability of JPEG 2000 to do a resolution progressive access and decode. And basically, this is the way this demo works is this is not EXR, right? This is just a MXF file that contains just a 4K, I think what it says here, 16-bit file, 16-bit file, 444 4K file. And there's a JPEG 2000 that's loaded in your browser when you access that site. And the decoder accesses that file over the network, right? Accesses the file that's stored on S3. And depending on your network conditions and depending on the processor you have on your machine or on your phone, will access and decode only as much of each frame as possible. And if you click pause, right, then of course it will download the full frame and give you the full resolution. So this is, this shows the ability, for instance, to browse very high resolution, very large, multi-layer OpenEXR frames over the network anywhere in the world, right? And you might not get the full resolution at first, but you can access every frame as they are without the need for proxies or maps. So anyway, so that's a cool feature that J2K enables, and we can look at applying that to EXR. I think that's it. I thought I'd leave some time for questions. So thank you again very much. And questions, comments, and thanks for the community for helping through, through the experimentation here and the integration. And I think it's been a really great experience. And anybody interested in contributing to OpenEXR, highly recommended. So 5 stars, we'd do it again.
Thank you, Pierre and Michael and Eus. Questions?
Yeah, don't be shy. I mean, you know where to find me, and we're on Slack, but yeah, Sam.
I was just kind of curious if anyone had done any substantial testing of the compression just to work out, like within a studio across a wide variety of image sources, whether what kind of compression ratios you're really seeing compared to kind of other existing OpenEXR things. We are very limited in like what you can easily get to. The Netflix setup is terrific, but there's only like one EXR set of content there.
Yeah, and actually, and one of the challenges has been getting. So it's hard for me to get my hands on studio content because it's studio content, right? So so in a sense, the goal here is relying on folks now that especially it's on the main branch, right, to experiment on their side and report any deviation from the results I reported. Now, the experience we have with JPEG 2000 again spans decades, and so I'm pretty confident that the results are presented, are what they were what I expected to see. So when we go to lossy, of course, completely different story, right? But for lossless, I think there's going to be no surprises essentially. So, for animation, you're going to get better, right? Because the less noisy, the better, essentially. But so I think for lossless, there's not a lot of question marks. For lossy, we should definitely need to do a more thorough study.
We've done some informal, unscientific testing and evaluation at ILM. Our experiences, we're getting about a 10% file reduction. But that was just on some sample images that we could find. We've not used it on a show, so we haven't seen how it's actually gonna scale to widespread use yet. But the initial indications were encouraging.
And sorry, that's 10% over PIS.
Yes.
Nice. Which is right in line with what Pierre, I think, had reported. Is
Yeah,
that right?
and I think
that's right.
your mileage may vary, right? If you try to encode super noisy, well, of course, nothing will work. And if you try to do animation, you'll get better. But
Yeah, and I think you can, now that it's part of the main branch, it's pretty straightforward to just use, I think it's called EXR metrics as a tool that comes with the library package, and you could just say, I want HTJ2K, and you can compare it to whatever file you have sitting on your disk and see if it's smaller. Okay. So we should be able to get more casually reported results that way.
Peter, you want to say anything about EXR metrics since you wrote it?
I'm not sure if my sound's working because I'm
Yeah,
on
we
a
can
weird
hear you.
laptop. Good, that's good. Yeah, so that's meant for this kind of benchmarking. It will report all the different compression things and also compression speed. It's kind of cheating a bit because you can't reliably measure the speed writing to disk. So it's basically measuring the memory compute time. So obviously, if the file is smaller, then writing to the disks are going to be quicker. But it's hard to get reliable metrics from that.
Timing metrics is always a challenge, but the file size is going to be accurate because it's just going to write a file, right?
Right.
Yeah.
Yeah.
So
And
especially
in
for
terms of
lossless.
compression ratio was what Sam's question was about initially. So that's why I mentioned the tool. But,
right,
yeah,
the test we've done has shown that that it's HTJ2K is significantly slower to write than anything else. So definitely would have to trade that off if you're looking at in production use. And again, you really have to measure that within the tools that are using it rather than in a more kind of theoretical test as well.
Anybody else?
Anyway, I'm on Slack, I'm on email, Discord, iMessage, WhatsApp, Signal. So never hesitate.
Our steering committee meetings are open to the public, so everybody is always welcome.
where we
Yeah.
may present some of the decorrelation results when we
Yeah,
have
that's
that
going to be
info.
super exciting. Optimal decorrelation is like that. That's actually super cool to see in practice, right? When you have, highly correlated channels and you process it and you end up with essentially one channel with a lot of information and all the other channels is basically no information. So that really helps with coding.
Yeah, Pierre, we should maybe at the next TSC meeting we should discuss whether we should inject an additional stage in the encoding well, I guess in the encoding pipeline.
Yeah.
To enable that sort of cleanly in that same C encoding pipeline chain there, right? That would be a cleaner way of doing that.
Yeah. I mean, yes. So no, yes. I mean, yeah. That's definitely an option to make it available to everything.
Mm-hmm.
And have fun about, do we do this across layers, across channels, across parts, and all this fun stuff.
No.
Yep.
Maybe.
Anyway, I think we should definitely talk about this, so I think that's the plan. All right. Anything
Okay.
else?
We'll
Thank you
call it
so
a day.
much.
Thank you.
Bye-bye.
Thank you, everybody, for joining.